Ordering of decimals. In the previous class, we have learnt about decimals. Let us revise quickly what we learned there. The fractions having denominator 10, 100, 1000, etc. are called decimal fractions. For example, 2 upon 10 is a decimal fraction, which is written as 0.2. Similarly, 18 upon 100 is equal to 0.18 and 45 upon 1000 is equal to 0.05. Fractions with 10 as denominator are called tenths. Fractions with 100 as denominator are called hundredths. And fractions with 1000 as denominator are called thousands. We read 0.2 as 0.2 and 0.18 as 0.18. 5.163 as 5.163. In a decimal, the number of digits after the decimal point is known as the number of decimal places. For example, in 0.72, there are 2 digits after the decimal point. So, it has 2 decimal places. Similarly, in 12.036, there are 3 digits after the decimal point, so it has 3 decimal places. Decimals having the same number of decimal places are called like decimals. Decimals having different number of decimal places are called unlike decimals. For example, in each 1.24, 0.08, 168.39 and 15.70, there are 2 decimal places. So these are like decimals. On the other hand, 1.5 has 1 decimal place. 21.092 has 3 decimal places. 0.39 has 2 decimal places. And 146.7 has 1 decimal place. So, these are unlike decimals. We can always convert a set of unlike decimals into a set of like decimals. Consider 0.3. 0.3 is same as 3 upon 10. Multiplying the numerator and denominator of 10 by 10, we get 30 upon 100. Written as 0.30. Hence, 0 and 0.30 are equivalent. Again, if we multiply numerator and denominator of 10 by 100, we get 300 by 1000. This can be written as So 0.3 and 0.300 are equivalent. Thus we say that 0.3, 0.30, 0.300, etc. are equivalent decimals. From the above discussion, we conclude that adding any number of zeros to the extreme right of the decimal part does not change the value of the decimal number. Doing so gives the equivalent decimals for the given decimals. Here keep in mind, we cannot put zeros in the left side of the decimal part. For example, consider 0.7. It is 7/10. We cannot write 0.7 as 0.07 because 0.07 is 7/100. Similarly, 0.7 and 0.007 are different. Now let us discuss how to perform comparing and ordering of decimals. Observe these figures. In the first figure, the shaded portion shows 1.6, and in the second figure, the shaded portion shows 0.6. Also, the shaded portion of first figure is more than that of the second figure. So we have 1.6 is greater than 0.6 or 0.6 is less than 1.6. Also, note it here that both have same decimal part but different whole number part. Thus, we can say that to compare two decimals, we first compare their whole number parts. Decimal having the greater whole number part is greater. Do you know what to do when both the decimals have the same whole number parts? In this case, we compare their 10th digits. Decimal with the bigger 10th digit is greater. For example, in 8.52 and 8.94, the whole number part is same, that is 8. The 10th digit of 8.52 is 5 and that of 8.94 is 9. So 8.52 is less than 8.94 or 8.94 is greater than 8.52. Again, if the 10th digits are also same, we compare their 100th digits. If the 100th digits are same, then compare 1000 digits and so on. Now consider 4.63 and 4.6. Here we first write 4.6 as 4.60 and then compare 4.63 and 4.60. In 4.63 and 4.60, the whole number part, that is the ones digits, and the 10th digits are the same. So we compare the 100th digit, that is 3 and 0. Since 3 is greater than 0, so 4.63 is greater than 4.60. Again consider 0.854 and 0.859. Here, the whole number part, that is the ones digits, 10th digits and the 100th digits are the same. So we compare their 1000th digits. Since 4 is less than 9, so 0.854 is less than 0.859. Let us arrange 5.63, 5.736 and 18 in descending order. Here we first convert the given decimals into a set of like decimals. Here the maximum number of decimal places is 3. So we write 5.63 as 5.630 and 18 as 18.000. Note that a whole number is a decimal with as many decimal places as required. Out of these, 18.000 has the greatest whole number part. So 18.000 is greatest. In 5.736 and 5.630, the whole number parts are the same. But the 10th digit of 5.736 is greater than that of 5.630. So, 5.736 is greater than 5.630. Then we can write the fractions in descending order as 18, 5.736 and 5.63.